But one of the more important experiments took place in 2016. Here the researchers built what they call the world's smallest heat engine. This was reported in the study, you can find in the description. But essentially here Professor Eric Lutz, who we'll discuss a little bit later because he basically has done it again, reduced the essential parts of the engine down to the ultimate limit, a single atom. And so by using a single electrically charged calcium ion, specifically calcium-40, trapped inside the electromagnetic device, they were able to recreate the idea behind heat engine. And to create the cold reservoir, they used laser cooling, dropping the temperature to a few microkelvin. But then to create the hot reservoir, they shook the ion with the electric field, which increased its kinetic energy by a few millikelvin. And so the process of heating and cooling caused this atom to oscillate back and forth, just like a piston inside the heat engine. And so this oscillation was then used to store mechanical energy, acting like a tiny flywheel. And this was a huge experiment and essentially a very important proof of concept, with a single atom achieving the output of approximately 3 × 10 to the power of minus 22 watts, but a very low efficiency of 0.3%. And so you're not going to be powering anything with this anytime soon, but it was still kind of interesting. Interestingly though, when doing calculations, they also discovered that the power to particle ratio here was technically comparable to a typical car engine. But critically, this also confirmed that the fundamental mechanism for macroscopic heat engines seems to indeed work in the subatomic world as well. So here they proved that we can definitely build these engines, even though